All right. So let's start off by just drawing this graph. And I purposely picked a graph that you probably don't know a whole lot about otherwise. That way you have to refer to it and see what's going on there. So just sketch yourself a little coordinate plane here. And then I'm going to point out some ordered pairs and things on this. So the first ordered pair on there is going to be 0, 4. And then the x-axis. Off there. The second ordered pair we're going to mark is pi over 2, 0. Pi over 2 is a number. Pi divided by 2, 3.145963. It's a number. It's the ratio of the diameter or the circumference and the diameter of a circle is what pi is, and then half of that. So that's what that really is. And then the next point would be pi and then -4 is an ordered pair. And then this next point here is 3 pi over 2, 0. It doesn't matter. Don't freak out, guys. It's just ordered pairs. They're just numbers. And then 0.5 pi over 2, 0. And then 3 pi -4. And then that's 7 pi over 2. Whoops. 7 pi over 2, 0. And then we'll do one more. Just up here. We'll call it 4 pi. And then the graph actually looks like this. I'll draw it. Goes through all these points. You may have seen that kind of graph before, but you're not really familiar with it yet. So it's a tree graph is what it is. But those ordered pairs are important. That's the main thing there. And I picked that one because they're different ordered pairs. They're not, so you don't have to get confused with whether or not you're calculating something or you're just getting it from the ordered pairs. And most of what we're going to do on this problem, we're going to get from the ordered pairs. Okay, so this graph is what we're going to base every question I'm going to ask here. We're going to base off of this graph, and then we'll do an equation, and we'll base everything off of that equation out of this. So you're going to be getting some graphs. You'll get some equations and stuff, and we're going to find a few things here. The first thing that we're going to find is what is f of 0. What does that mean? What does this 0 represent? X. Okay, so it represents x, like f of x, f of 0. So what's the answer to that? When x is 0, what's y? 4. That comes from that ordered pair right there. Here's the x is 0. There's the y that goes with it, so it's 4. F of 0 would be equal to 4. Question number 2. F of 3 pi over 2. What's the 3 pi over 2? It's what coordinate? X or y? It's an x coordinate. So the y that goes with it is 0. That's why it's 0. Okay. So given something like this, they're giving you the x value. They want the y value that goes with that. That's what they're asking for there, without saying a whole lot. Just using that notation to help you. Okay. All right. I'm about to scroll down and scroll kind of back and forth here between our picture and the questions that I'm asking. So several questions that we'll ask about this just each thing. What's the domain of this graph? Remember, the ordered pairs aren't the only things on the graph. That big blue line represents all of the ordered pairs that exist on there. So the blue line is actually the graph of the function. So the domain covers what? All the x's that are used. What's the smallest x that's used here? 0, good. And then what's the largest x that's used? 7 pi. 7 pi over 2 is here. And then that would be, that's 4 pi, right? That's the furthest one to the right, okay? Are there any holes in the graph, like empty spots? Numbers that were skipped? There aren't? There are x values that were skipped? I mean, like, they left a blank. No, there are no blanks there. And a lot of times, if there is a blank, what they're going to do is put an empty circle, like, in the middle of the graph. They'll put, like, an open circle saying, we're skipping this number out of that. There are none in this one. So the domain for this particular graph goes from 0 to 4 pi. Are those included? Why are they included? Because they're on the line, and the ordered pair that's marked for those is filled in, right? It's not an empty circle. So those are included. So the domain would be from 0 to 4 pi, including both of those. So a bracket on both ends there would be the interval notation for this. Yeah, let's go ahead and do the set for that as well. That's what the interval is kind of the default that I go to. We want to be able to bounce back and forth during the first couple of chapters here. So what's the set notation for that? It's not all real numbers. It's from zero. Your interval is 0 to 4 pi, so your set's got to say the same thing. Good job. So a compound inequality could be used to do that. 0 is less than or equal to x, and then it's also less than or equal to 4 pi. So that's saying start at 0, include it, go all the way up to 4 pi, and include it, just like our interval notation says that. Okay. So here, this is one of those situations where Dylan was saying that the interval notation is more complicated than the set. But this is one of the, you said that last week. So this is one of the places where I think the interval is a lot easier than the set is in this case. It's one of the few places that happens, but it does happen that way. Let's talk about range. Spent a lot of time doing domain with the first section, so let's talk a little bit about range. And this range deals with what? The y values, okay? So if we look at that graph, range goes up and down, so we're going to start, what's the lowest y value on that graph? -4 is smaller than 0, so -4 is the lowest. What's the highest? 4. Are those included? Yes, so the range would be from -4 to +4. Yes, that's exactly right. Good. I hear what she said. She said they're included if there's not a hole or empty circle on the graph. That's how you know they're included or not. Okay, so the interval notation from -4 to +4 included with brackets. So the set notation for that range, we'll use y because that's what uses that. It's very similar to the range or to the domain was. So it would be from -4 less than or equal to y less than or equal to 4. That would be domain deals with the x's, range deals with the y. That's the difference. Notation wise, they look the same, other than that, domain and set notation is x, and then range y. So, but in interval notation, they look very much the same. So, all right, let's look at question 5. This is a different one. How many times would y equals -2 intercept the graph? What does the graph of y equals -2 look like?
Horizontal line.
Yeah, horizontal line at what? -2 on the y-axis. So that would be, if I drew that in here, it would be this line right here. Right? That would be the graph of the line y equals -2. How many times does that intercept our blue graph? 4 times. 1, 2, 3, 4. And really not a whole lot of other ways of checking that with this particular type of problem than just graphing it and checking it that way. So 4 times. On a 4 answer in this one. Where is f of x greater than 0? This is always a good question. Where is f of x greater than 0? What does that mean? What is f of x? It's y. So all that's saying is where are the y values greater than 0 on that graph? So we're trying to answer the question, where are the y values greater than 0? It really comes in handy because we're going to have several places in this graph where the y values are greater than 0. Okay, so here's our y-axis. That is 0. I mean, our x-axis right there, that's the y value of 0. So greater than 0 would be above it, right? So what's that first interval of x values that are above that? From 0 to pi over 2. The y values is what we're checking. But what we're reporting is the interval of x values. X tells you where you're at on the graph. Y tells you, up or down, all that. So we're checking the y values, but we're going to say the where comes from your x values. So the interval we need there for that first part is from 0 to pi over 2. From 0 to pi over 2. Is the pi over 2 included? Why not? It's on 0. It's not greater than 0. So that not having an equal to mark is important there. If it had an equal to mark, you put a bracket on that. Okay. Okay, where's the next place on our graph where that is greater than 0? All right, so it's positive there. I agree with that part so far. Is it still positive on this part? Y values are not positive right there? Yeah, they are. So it starts at 3 pi over 2. It's positive, 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 up to 2 pi, and it's still positive going down this way until I get to there, which is what x value? 5 pi over 2. So the interval for the next piece that's greater than 0 would be from 3 pi over 2 all the way to 5 pi over 2. Yeah, it doesn't necessarily matter where the top part is. It's where's as long as the blue line is above the x-axis, we're good. Okay, so we're going to say that's from 3 pi over 2 to 5 pi over 2. Now, do those have brackets or parentheses? Both of them? Both of them have parentheses. Okay. Then let's get the other interval where it's greater than 0. Where's the next place? So at 5 pi over 2, it drops below 0 or equal to 0 and then below. So it's negative here, negative, negative, negative until I get there. And then it starts going positive after that. So from 7 pi over 2 to, no, not infinity. Our graph doesn't go to infinity. It goes to 4 pi. Because notice the graph doesn't have an arrow on the end. It's got a dot. If it had an arrow, yes, instead it kept going up, then it would be infinity, but it's not. So brackets or parentheses on that? Parentheses on the left, bracket on the right is what that should be. So you've got 3 interval notations here for where are the y values greater than 0. So you're going to look at the y values, but you're going to report the x values. That's what you're going to do. You're going to look at the y values are what's happening. The x values are where it's happening. That's the key to those types of problems. We could do another problem here. If we just swap that to a less than symbol, you would get 3 intervals where it's less than.
What are the x values? We just wrote down.
Why are they not included? Because they're equal to 0. Like at pi over 2, that's where it was on the x-axis, and the y value there is equal to 0. Our inequality didn't have the equal to mark, so that's why we don't include them. Good question. All right, so if you flip that around, you could do the intervals for less than 0. You're looking at the y values, report the x values. Really, it seems to be one of the tougher things. The intervals are the numbers that are in your intervals are x values. So that's where it is. The y value, it says where is f of x greater than 0, so it's asking where is y greater than 0. The where part is x values. The intervals are going to be your x values, not your y values. I didn't write y values on there. Those are all x values. Yeah. All right. Let's do this one. Kind of a similar problem. Where is f of x equal to -4? Look at that graph. F of x again represents what? Y. So we're looking for where the y value is -4.
However, 2 is 0. However, 2 is 7.
Not going to be an interval here because we're looking for an equal to. There's going to be one spot. Pi. Yeah, so we got that ordered pair pi, -4, and then we got the next one over there to the right of that, 3 pi, -4. So the answers for this, 2 different answers. You got x equals pi and x equals 3 pi. All right. There's some various things there going on with this particular problem. Let's get one more thing. Kind of an important thing here, so I'll put it last. Intercepts. Kind of a vague and generic term. But what intercepts are we looking for when we look at a graph? X and Y intercepts. They're looking for points on the x-axis or on the y-axis. Those are the important intercepts that we'll deal with from here until the end of this class or end of your mathematical careers. X and Y intercepts. So X intercepts and then Y intercepts. Doesn't have to be the same number of each of those. Won't be, most likely, in most cases. So let's get the easy one out of the way first. What's y-intercept? 0, 4, right? Is that ordered pair, 0, 4? What are our x-intercepts when we look at that graph? Pi over 2 is 0. 3 pi over 2 is 0. Yeah, 4 of those right there. All 4 of those ordered pairs are x-intercepts. because they're on the x-axis. So where, here's where it kind of, some people get confused. Here we have interval notations. Here we're using ordered pairs. When you do intercepts, you're using ordered pairs. With domain, range, intervals, you can get confused. They look the same. So we've got what was it? Pi over 2, 0, 3 pi over 2, 0, 0, and then 7 pi over 2, 0. And we have, those are our x-intercepts, ordered pairs for our intercepts. Okay. All right. Not too bad. When you're given the graph, you base everything off of what's happening in the picture you're given. Okay. Let's look at, what if you're not given the graph? What if you're given f of x is equal to x plus 1 over x plus 2? And obviously we have a graphing calculator. We could graph this thing if we wanted to and build off of that. But this is probably a graph that you're not as familiar with. It's got a couple of different pieces to it. And I argue that you don't really have to have the graph if you've got the equation. You can find everything you need based off that equation and some general knowledge about functions. So let's start with the first question I want to ask is, what's the domain? Just a quiz over this. How do you find the domain of that function?
X such that x is not equal to.
All right, x can't be 2. That's true. So x,
Is it negative 2?
yeah, negative 2. X can't be negative 2. How do we know that?
Because you said it equals 0.
Yeah, you said x plus 2 equals 0 because there's that red flag of an x in the denominator, and that's how you get that. So what's the interval notation for that?
Negative 6, infinity, negative 2,
Good. Infinity didn't work out good. There you go. So there's a domain. Because negative 2 is the only number I'm skipping. So I'm going to go from negative infinity up to negative 2 and skip it, and then pick up right after negative infinity. So the u joins those two pieces of interval together for a domain. Domain has to cover from negative infinity to positive infinity somehow based on your interval notation. The u is what joins it together to allow it to continue on. When you're talking about domain, you need that. When you're talking about the intervals of where it's greater than or equal to 0, or greater than 0 or less than 0 or whatever, you don't have to have the u's when you're doing those. Okay? Domain and range would be the only time you'd have to have that. All right, so let's look at this question. It's an interesting one. Is 1 comma 1/2, the ordered pair, x equals 1, y equals 1/2, on the graph of f of x? How could we determine that without graphing? What do you mean? Good idea. I like it. Let's try that. So I'm just going to plug in 1 for x, and it should equal 1/2 if this worked out, if this point is on the graph. But it doesn't. Equals 2/3. So is that ordered pair on the graph? No. So we can take the x value, plug it in. If it doesn't work out to equal the y value, it's not on the graph. Maybe they wanted it to be, for whatever reason. There may be some kind of application of that you could come up with. A little algebra here. Some of you will be delighted that that's happening. Some of you may not be. Where is f of x equal to 2? How could you find that? Okay, so you're saying 2 is equal to x plus 1 over x plus 2. Well, that's an equation. How do we solve that? Anybody remember from Algebra 1 how to solve that? Okay, yeah, good. Multiply by x plus 2. And then, so if it's x plus 1 on this side, those cancel each other, and that's 2x plus 4. And get x together, numbers on the other side, right? Minus x, fine. And I'm on minus 4. Do 2 steps at once there, so x is equal to negative 3. Because I was given an ordered pair on number 2. There, I was given the ordered pair 1, 1/2. I just plugged in the x to see if it would get me the right y value. We saw that it didn't when I plugged it out. Here, it's giving me f of x is equal to 2, which is actually the y value. So I'm setting, instead of, my equation was f of x equals x plus 1 over x plus 2. Well, I've replaced f of x with 2. And I've got an equation to solve. So I'm just replacing what they give me. Here, I could have replaced either one. But it was easier to replace the x with 1 and do the math than it was to try to solve that thing for x. This, I didn't have a choice. So x equals negative 3. That's the only place that f of x is equal to.
Mr. Israel?
Yes, ma'am.
I need Vivian Martin. Checking out.
Checking out. Okay.
Thank you.
All right, we're just about done. If you can wait just like 3 seconds. Last question. Intercepts. Again, what intercepts are we finding? X and Y. All right. Where do x-intercepts occur? X-intercepts occur on the x-axis. It's crossing the x-axis. What's the y value on the x-axis? 0. So we're just taking x plus 1 over x plus 2, setting it equal to 0. Finding x-intercepts. This is what you did in Algebra 1 to find zeros of a quadratic. So what you did in Algebra 2 to find zeros, you set the thing equal to 0. You find the x-intercepts by setting whatever your function is equal to 0. So we got the equation. This one works out really easy because it ends up just being x plus 1 equals 0. Because when you do the same steps that we did on number 3 and multiply by x plus 2, multiply 0 times x plus 2, it's gone, right? So then we just get x equals negative 1. So negative 1, 0. That's the only x-intercept we have for this graph. Y-intercepts occur where? On the y-axis, which is where x is equal to 0. That's right. So we just plug a 0 in for x. So we just find f of 0, which is 1/2. 0, 1/2. One x-intercept, one y-intercept. Out of that one, nothing else going on. Okay. You might have more than one if you've got like a quadratic or something that you got to solve. That doesn't come up a ton in this section. We'll do a whole chapter about linear and quadratics here before long. Okay. All right. So the suggested problems. On page 224, where it starts 9 through 47. If you do the odd ones, you should be good. If you struggle with some of the odd ones, then do the even ones beside it and get some help, with those. out of that. Today, you got about 20 minutes left in class, 18 minutes left in class, and you got a work day tomorrow. I will not be here tomorrow. My mom has a doctor's appointment, so it's the week full of wonderful doctor's appointments this week. But you got a work day tomorrow. Check your work with my textbook. Feel free to email me questions if you've got them. Friday, we will come in. We'll quiz over section 3.2 and then do the lesson for 3.3. So, and then Tuesday, we're out Monday for MLK Day and President's, or they combine a couple holidays in January. So I was just talking Martin Luther King Jr. Day. So that's Monday. So Tuesday will be a work day after the lesson on Friday. Okay. So, and then hopefully we'll kind of get into a little bit more of a rhythm. Get some things out of the way here at the beginning here. It doesn't look like there's any chance of snow in the next week and a half. So, all right. Vivian.